Section 5.4 is all about complex numbers. And our chapter 5 is all about solving or quadratic equations. So when we solve quadratic equations, we're going to get complex answers. Imaginary numbers are a part of a complex number. Complex numbers typically have two parts, a real part and then an imaginary part. So we're going to just talk about these imaginary numbers for a moment. What is it? Imaginary numbers deal with an I. An I, by definition, is going to be set equal to the square root of a negative 1. Somebody in class, either in this class or the next class, asked, well, what if we have the square root of a negative? That's whenever we throw out i's and we start realizing there's a whole nother dimension that we haven't even discussed. And it's the stuff we can't see. We deal that with i's. Let's say I'm solving a problem and I all of a sudden hit square root of negative 9. Well, I know what the square root of 9 is. Square root of 9 is 3. But now this negative, here's how it's going to be represented. I'm going to break it up into two pieces. Square root of 9 is like negative 1 times 9, which, in a sense, is like square root of negative 1 times the square root of 9. And the new thing is realizing this is now going to be represented as I. So I've got I times the square root of 9. But wait a second, what is the square root of 9? Couldn't I have just said that that's a 3? But we write it like a normal term where the variable goes after the coefficient. This I represents that square root of negative 1. I can either start breaking it up and realizing, okay, this is like square root of negative 1 times the square root of 121, which turns into, we're now learning that square root of negative 1 is I. We would write it as 11i. Let's try to figure out what I squared is. Because we got to make sense of, what if I take an imaginary times itself? If I decompose this, it's I times I, which is the same as square root of negative 1 times the square root of negative 1, which is the same as the square root of negative 1 squared. So when you take an I and you square it, this square root undoes this square. You're left with that negative 1 that was originally in the radicand. First example, what if we have x squared equal to a negative 16? X squared equal to a negative 16. We can either make the choice of trying to factor or using the square root method. My suggestion here is just use the square root method. Take the square root of both sides, include the plus or minus, and then we have x equal to plus or minus, square root of 16 is 4. The square root of this negative 1 is I. So plus or minus 4i. Next example, 5y squared equals negative 40. We're going to treat it again. Let's use the square root method. Eight breaks up into 4 and 2, so we have a pair of 2's. So this y is equal to plus or minus 2 root 2. Ooh! And we have to include that I. Thank you.
Wait, so you lose the negative? The fact that it was a negative 8, you just put the I in that place.
So, since it was square root of a negative 8, square root of a negative 1 is an I. And notice where I place the I. I put the I in front of the radicals. We could, you got to be aware, you could have the I at any place. I typically like to put it outside of the radical, or I say before the radical, so you don't think it's still part of that radicand. I like to separate it, but be aware, it can be written the other way on the ACT. this I could have been written after the radical. That's fine. I just like to write it before the radical so you don't think it's part of the radicand anymore. Once you label it with an I, it's assumed you're just talking about a square root of -1. Be sure it's not underneath this anymore. We're going to treat them like terms. We're going to write the expression as a complex number in standard form. A complex number in standard form typically has a regular number plus or minus an imaginary part. So we may have a 3 plus or minus 2i or 2i root 2. The imaginary part goes second. That's what standard form means. You're going to have a real part, something without an I. And then you can either have plus or a minus, something with an imaginary part. So, first example, we can add complex numbers, 5 plus 4i, plus another complex number, 7 plus 2i. Treating them as like terms, we'll call these a real part, because they don't have the imaginary part. So I have 12 total for the real part, and then for the imaginary parts, I have 6 total. Sometimes we need to be wary and we still have to distribute that minus sign. Signs should change on that set of parentheses. I only have one real part, one real number, and 2 imaginary parts that I got to get together. If I were to write out the distributive property, we get -2i times 5 plus, or I guess, minus 2i times I. First term is -10i, but the second term becomes minus 2 times I squared. This I squared is a -1. So now we have -10i plus 2. And if I wanted to write it in standard form, most of your answers or most of your textbooks or tests put the real part first. 4i times the quantity, 3 minus 5i. And I'm just going to show these little arcs. If you took 4i times 3, you're left with 12i. When you take 4i times -5i, you get -20i squared. But this piece in the next step becomes -1. Sometimes we may have to FOIL or double distribute. What if we took 2 plus 3i times the quantity 2 minus 3i? 4, and then outers, or 2 times -3i is -6i. Inners, 3i times 2. And last, we get -9i squared. And this is the new piece that we need to recognize. Last term becomes plus 9, 13.